Hi there, I celebrated my 75th birthday this week, and so I thought I'd share with you something that's even older than I am. And that's Euclid's proof of the Pythagorean theorem. It's a really simple proof. It only involves one idea. And let me just start out by saying what we're going to do is we're going to show that the area of this square on this side of this right angle triangle is the same area as this rectangle down here, part of the square on the hypotenuse. And that this area of this square over here will match the rest of the square on the hypotenuse. Now, as I said, there's one simple idea that's going to be involved here, and that's the fact that if you have a triangle whose base is exactly the same as the base or length of a rectangle, and its height is the same as the height or width of the rectangle, the area of this triangle is exactly half of the area of the rectangle. The rectangle area is length times width. The triangle is base times height divided by 2. So it's exactly half of the area of the rectangle. I'm just going to do this by sliding a couple of triangles around. If you want to see an actual proof, Euclid wrote a number of books where he proved a lot of geometric facts using these triangles. And in his book 1, Proposition 47, he proves the Pythagorean theorem. So here we go. This is the original diagram that I showed you before. I've got a couple of extra lines drawn though because I wanted to show you a triangle up here and a triangle down here. Once again, the triangle we're talking about is this one here. The right angle is there. Here's the hypotenuse. So I'm going to set this triangle on here. If you think of this as being the base, then this is the height of the triangle. The height falls outside the base. So here's the base, here's the height. So base times height divided by 2. And you notice it's now exactly half the area of this square, because the area of the square is this side times this side, and the triangle is base times height divided by 2. Now, this angle right here is made up of a right angle and this little slice in here. So that means if I take this, I can just rotate it down here and that angle will fit in exactly. Now the base is along here. Here's the height. So base times height divided by 2. It's exactly half of this rectangle over here. So at this point what we've got is that this area matches the area of that rectangle. Now, most books at this point would say similarly, but I'm going to actually show it to you. Similarly, over on this side, if you put this triangle on here, use this as the base, it comes up way over here, but this is the height. This is the height of that triangle, and it's the same as the height or width of this square. So once again, the area of this triangle is half of the area of this square. And as we did before, just going to rotate it around here. And at this point we're going to say this is the base. Doesn't matter what side you take as a base of a triangle as long as you get the appropriate height. So this is the base along here. This is the height up to here. Base times height divided by 2. So it's exactly half of the area of that rectangle. And we're done. We've got the area of this square matching down here, the area of that square matching down here, and the sum of these two then give you the area of the square on the hypotenuse. So if you don't like numbers and you still want to do math, look up Euclidean geometry and you can see how to prove a whole bunch of stuff without actually having to add, subtract, multiply, or divide. Bye for now.